Cool. So does everyone have the notes just to make sure everyone's got access to that? So Jay, the way we usually do meetings is just like give sort of a quick round of updates, and then we can go into longer discussion items. But maybe for the first thing for quick updates today, we can just like each do quick introductions just so you know who you're talking to.
Yeah.
And maybe we can give you a quick overview of who else is usually involved and such too.
Okay.
So I will maybe start. I'm Lindsay. I am at UC Berkeley these days. I did my PhD up at UBC in Vancouver. So that's where a lot of the SimPEG development started. But now I work on basically Jupyter in the geosciences. So still doing a lot with SimPEG, but also now with the Project Jupyter team here. Yeah. Joe, do you want to go next?
Is Joe frozen?
Oh, right, so if you can't hear me or if there's a lot of background noise, let me know and I'll try to yell louder. There's a bit of construction going on. So my name's Joe Capriati. I am at School of Mines in Colorado. So Jaja, I knew Jaja. I worked with him for a long time. So nice to see his students. I don't, just been helping out. Well, I don't know. Sitting outside, it's nice.
Joe is the master behind meshes. So all the tree meshes are Joe's. The full optimization. He's too modest.
Anyway, yeah, I've done a few of that. A few things on that, pushing on the discretized side. But that's not related to my research. My research itself is on coupled inversions, fluid flow coupled inversions. That's me.
Excellent. Thanks, Joe. Dom, go for it.
I'm Dom. I'm the one who replied first to your post. I'm finishing my PhD at UBC with Doug Oldenburg, and mostly the potential fields, focusing on that, and then regularizations, directives. So yeah, glad that you join us. Go for it, Jay.
Okay, yeah, well, again, my name is Jay Kim, but you can just call me Jay. And yeah, like I'm a master's student. I'm on my second year, and I'm doing joint inversions mostly with the cross gradient, but I'm also working with the normalized cross gradient, and mostly with gravity magnetics.
Excellent. John, go for it.
Yeah, I'm interesting.
Sorry. Oh, yeah, I'm John. I'm just kind of just doing. I work in the industry. Work for geophysical, mostly DC and now MIG radiometry, a little bit of MT as well, and just helping out where I can. That's me. I supply beer sometimes too.
Yeah, so you'll need to come visit in Vancouver, Jay, if you want to sample that.
Good lubricant for coding.
Turn beer into code.
Excellent.
The Messiah.
And then it looks like we have some of the UBC crew joining. I see a table. Is there anybody at UBC who wants to say a quick hello and introduce yourselves to Jay here?
I'm Mike. I'm just finishing up my PhD here at UBC, hopefully soon. Well, hopefully this summer. I guess I'm working mostly with DC resistivity and EM problems. And most of them like in an underground or kind of in mine environment. So just kind of how we can kind of better design some of those surveys to get some better inversions out.
Hi folks, I'm Kevin, and I'm a research assistant working with Doug. And yeah, I'm doing, I guess, a hydrogeophysics project, which Lindsay and Sandy are also involved with. In Miami, I'm trying to look through water there. Yeah, and it's mostly in DC. There's a possibility of IP. Nice to meet you.
Excellent. Is that everybody at UBC? Is Vahid there?
Yeah.
Wave. Yeah. Hi, Vahid.
I'm not sure where he went, but
okay. That's all right. Vahid's another researcher at UBC. He's a professor who's doing an exchange theory student sabbatical there, getting connected with the group. And then a couple other key people who are, looks like, not able to join us today. So Sagi Kang, he is at Stanford. Also did his PhD at UBC, and he's now doing a lot of work on airborne electromagnetics for groundwater. And then Thibaut Astic, he is doing a lot of work. Actually, I think you guys will connect well. He's doing a lot on incorporating petrophysical information in inversions. And so he's also done a lot of work in the regularization side of things for incorporating extra information. And then Doug usually joins us as well, and he is a prof at UBC. And so most of us worked with him. Yeah, so I guess that's most of the people. So for just like maybe quick updates for everyone, and then we can let Jay take the floor and give us an overview of his work and his issue that he's started. Just a quick couple of things from me and from last week is wrote up a quick blog post about the meeting that we held in Montreal. So take a look if you have extra suggestions or things that are unclear. If you guys have questions, invariably other people will. So happy to take those and provide some clarification or adjustments or such. Yeah, it was a productive conversation. So hopefully the blog does some justice in capturing that. The next item that I had is that Dieter has been working on an example that incorporates a few different open source Python packages. So actually starting from doing some modeling with GeoSci.xyz, which is a geologic modeling package, and then bringing that over to Discretize. So ideally we can then start running simulations on it. He was having some trouble. I think he started with MT. And the MT code is just not quite as mature as some of the others, so it might be better if he runs potential fields. So I was wondering, Dom, if you might be interested in taking a look and maybe giving him some pointers, if you have bandwidth for that, or if not, if somebody else would be game to jump in.
Yeah, I would love to. Yeah, GeoSci was on my radar for a while. Did you post the link anywhere?
I don't have it handy, but I can ping Dieter and we can get that moving. Yeah, I don't have it offhand.
Yeah, that would be the easiest.
Yeah. Excellent. Thanks, Dom. That'll be really cool. I think that like combining, an entire workflow where you're actually doing like geologic modeling with GeoSci and then going through and running a simulation with SimPEG is pretty compelling.
So do you know if he's actually creating a block model out of it, or is just from surfaces?
I believe that he's got it all the way to Discretize.
Right.
So there's a block model that's been created.
Cool. Yeah, that's great. I'm in.
Excellent. And then the last quick one from me was that Craig posted an issue on SimPEG about potentially doing a user survey. The timing, we were sort of thinking after the simulation release, to get a sense of just like what pain points are for people, where to perhaps focus efforts on docs and examples and things like that, and maybe get some input on like how people actually want to interact with the code as we move forward. So if you have like ideas of questions or people that we should reach out to, feel free to add your thoughts there. That's all from me. So Dom, it looks like you have a quick update. Today,
slowly working on the simulation refactoring for potential fields. I kind of got lost though with our conversation. I have a question for you, Lindsay. So what do we want to do? So we agreed that like a receiver list could have multiple components, right? Mm-hmm. So in case for magnetics, you could have TMI and the gradients all attached to the same receivers, right?
Yeah.
how are we going to deal with cases where, let's say, people edit out a few, so not all receivers have all the components. Like, are we going to have, like, can we have an index, like, I don't know, a bool of true or false or something if they're kicked out? What do you think?
Yeah, so I think the extension we thought about there is that, so the simplest case is that the receiver list could take a list of components, just like you said, so TMI, gradients, whatever. The more power user case would be that thing be a dictionary. So then be TMI colon an array of bools that correspond to whichever data are collected versus not. And then the next item would then be like a gradient, and then its value would be an array of bools. Does that make sense?
So the actual receiver object will have it, not the survey.
Yes, correct.
Okay. Yeah, I think that makes sense. Yeah.
Excellent.
Okay, so a dictionary with the keys being the components. Sounds good. Yeah, that answers the question.
Okay. Cool.
And if it's okay with you, I would ask the potential fields part, because I was starting to bring it back multiprocessing for parallelization and everything, but then if we're going to revert back to Dask later, so I will just keep Dask under the hood in the PF, and then we can move it one layer up later. That's good.
Yep, that's totally fine.
Perfect.
Yeah, so feel free to just add Dask to the SimPEG requirements. I mean, it's going to be coming in anyways, so like there's no sense in sort of like trying to arbitrarily pull it out and then strap it back on later.
Excellent. Yeah, so I think it will go pretty quickly. I needed another probably full day of work, and then we should have something for you to look at.
Excellent. That's exciting, Dom. That's really exciting.
Yep.
Cool. Any other quick updates? Things people want to jump in on?
Well, I almost have the Dask implementation for the DC problem there, forming J. Just curious on, like, when you form J, or what problems are you forming J not explicitly, the whole J matrix? What is the what are you doing with it afterwards?
Well, like, I can use just a preconditioner, right? And then the sensitivity weighting. So you get, and I guess all the matrix vector products are much faster after you formed it, right?
Yeah, exactly. I was just wondering, like, if I should just, when you call like get J, are you just summing along the columns to get the pretty much JT diagonal?
No, okay. Get J would actually just point to your ZAR file, because you're going to start it to ZAR, right?
Yeah, the full J, I'm going to start with J. But if you're just doing the products afterwards, there's no point.
Yeah, the get J, I'm not sure if it's really going to be necessary anymore, because we can. I don't know. We'll have to look into it, but it's kind of weird, right? Because we're never going to bring it all to memory anyway.
Yeah.
So we might have to rethink that part.
Okay. Sorry.
I don't think the get J is used many places, because now we're using get JTJ diag, right, for the preconditioner. So
yeah, that's what I was kind of going through, and I didn't notice it was used so much. So I was wondering, what is it actually? Is it going to be a prime thing to have, or just store it to ZAR? And
I'll do a search in a stack, but I don't think get J is used much.
Okay.
Maybe we can take it out or something. I don't know if other people have strong opinions, but.
Yeah, I think the only places right now where it would be used is, in some cases, it's stored in the DC inversions, and then perhaps in the potential fields. But like in the EM codes, we won't be storing J.
Okay. Well, let's then I pretty much got everything going. Maybe a little bit half day of work here, and I should have something. Maybe Dom, you can take a look and.
Yeah, which branch are you working on?
I'm off the simulation branch right now.
But you have your own, right?
Oh, I haven't started my own yet. I was just going to get some stuff done, and then I was going to create a new branch.
Yeah, I'll gladly look at it for sure. Just push something, and then give me a notebook or a script, and I'll take a look.
Right on.
And so the A inverse, the solvers is fine, right? You're saying?
No problem at all. I thought there was going to be a little bit of hiccup there too, but yeah, it goes along, no problem.
So each worker only uses like its own threads. Well, how does that work?
Right now, to my knowledge, yeah, that's all I'm doing. Is just it's using its own threads.
Wow, automatically. Sweet.
Nice when things just work.
Yeah.
Yeah.
Cool. Any other quick updates, things people would like to chime in on? No? All right, well then, Jay, we will turn the floor over to you.
Hi, okay. So I have a notebook. How do I share?
So it looks like if you mouse over the window, at the bottom of the screen, there should be a share button. It's like a green square
Okay.
arrow.
Can you see it?
Yes.
Okay, yeah, so just I created this, it's just a brief overview of like what I'm doing. So like in the joint inversion, some of you might already be familiar with, we're given multiple data sets and then we're inverting them simultaneously to get multiple physical property models, but in a way that they're consistent in some predefined way. So Thibault, you said he's working on petrophysical relationships. I'm working on structural relationships. And so my objective function looks something like this for the case of a joint inversion of two models. So I have like two data misfits, two regularizations, and then a coupling term. And this coupling term is what quantifies the relationship between model 1 and model 2. And well, for my research right now, I'm just using what is called the cross gradient. And the cross gradient is defined as like the cross product of the spatial gradients of two models. And we're taking the sum of all these cross products over the whole model space. And so we want this sum to be close to 0 for models to be more like similar in structure. And so what I've done is just like, I wasn't sure whether the coupling could go under a regularization as a subclass of regularization or just a class on its own. For now, it's just a class on its own. So just to show you what it looks like, what I've created is, I have two models just that are not similar in structure. Like there's some difference in the structure. And so what the cross gradient does, it computes to a non-zero value. So that's what the cross gradient does. But then what happens when the models are identical in structure? The cross gradient is going to compute to 0. But it also computes to 0 when the models are not overlapping at all. So like it won't enforce a structure that is not present on the other model. So just that's basically what the cross gradient does. And so yeah, the ideal case would be that we run our joint inversions using SimPEG. And to do so, what I've had to do is I've had to make some modifications, mainly on the inv problem class. So we can restate the objective function in terms of a single stacked model where we're basically concatenating just model 1 and model 2. And then we can take advantage, then we're solving just a Gauss-Newton problem. And then we can take advantage of the optimization code that is already in place in SimPEG. And so thanks to some like early responses that I got from GitHub, I've actually been able to do this using a combo objective function. So what I do first is I define a wire mapping that basically just maps from the stacked model to the individual models. And then taking, for instance, a gravity and magnetics joint inversion problem, I pass the different mappings to each problem. And then when I define the data misfits, I can combine them together as a combo objective function. And then when I compute like the derivatives, it will compute the derivatives stacked on top of each other. That's exactly what I want to do. So that works. And then the same thing with the regularization. Like I just need to pass a mapping to the regularization objects separately. Then I just combine them together. And then when I take the derivatives, it's going to compute the derivatives on top of each other. And then for the coupling is just a function of model one of the two models, model one, model two. So the derivatives, the dimension of the derivatives are going to be consistent with all the other derivatives. And then by constructing the derivatives as shown here, I'm able to take advantage of all the optimization code. And then it's just a matter of small tweakings that I need to do to run the joint inversion as part of SimPEG. So that's basically it.
So what was your modification to inverse problem then? What did you have to do, Joy?
Oh, so yeah, what I did really is just I created a new subclass of base inverse problem called joint inverse problem. And in the eval function method, that's where I define how it computes the value of the objective function, the first derivative and the second derivative.
And was that then because you didn't necessarily know about the wires and the combo objective function before? Has that sort of addressed, or are there still things that we're missing in that framework that you want to make sure get included in like the way that SimPEG thinks about inverse problems?
So like the data misfit and the regularization is taken care of using the combo objective function, but it's the coupling part that I'm not sure how to include as part of whether it has to be like, I wasn't sure whether included to the base inverse problem class or I had to create a new one. For now, I just created a new one. But if
I think it's going to be a regularization, right? It's going to be a regularization that will take that will know that we'll need two wire maps basically inside your regularization, and then grab the right models and then do your calculations and then spit out derivatives. I think it has to be in the regularization.
Okay, but so like, do I create just a subclass in the regularization class, like the file?
Yeah, so that I think actually what we should do, and this doesn't stop you from starting to play in the regularization file right away, but right now the regularization file is enormous.
Right.
And so what I think that we should do is actually just like break that into a folder and break out like the regularization mesh, Tikhonov style regularization, the sparse stuff that Dom's done, and then actually focus in on coupling or sort of joint inversion tailored objective functions, just so it's a little more clear like where stuff should live. Because I completely agree right now, yeah, it's not necessarily obvious that the cross gradient term should fit into the regularization. But does it make sense what Dom's suggesting with just providing essentially like two maps, or like two wire maps basically to a to the coupling or sorry, to the cross gradient term?
Yeah, it does make sense.
Cool.
Because you'll need your derivative operators and all that, right? So you can take it from the reg mesh and then just have a fancier derivative.
Okay.
Do you need to store a model when you do the cross gradient? Does it depend? Is it a nonlinear problem?
Yeah, well, like during the joint inversion itself is it makes it nonlinear. So yeah.
But do you need to actually like clarify? Sorry, feel free to jump in, Dom, if you think I'm misrepresenting this. But I think what Dom is referring to is that there are cases where we have regularizations that actually need to know about the previous iteration. Like they need to know about the previous model. With this one, you don't need to know about the previous model, right?
No, I don't.
Yeah, so all you need is the mappings, and then at every iteration, we just simply compute the cross gradient, right?
Right.
Okay.
Yeah, okay, that's what I meant. Thank you.
Hi, Lindsay.
Hey, Chantel. Good to see you.
Good to see you.
She just can't stay quiet.
From what I understood, the cross gradient itself is nonlinear operation, right?
Yeah.
So I don't think you need to store the model itself. Like the gradients of the models are needed.
I'm sorry, I couldn't hear you.
The gradients of the model are needed in order to compute and recalculate like the derivatives and the the second derivative of h, the
Right,
Hessian
yeah.
matrix.
But I don't need to know like the previous iteration. Like I can just take the current model and then just compute together the spatial gradients.
Yes, but like when you're inside the Gauss-Newton iterations and you do a bunch of CEGs, right? It's going to call deriv a bunch of times.
Right.
If you need to store that model and keep those weights fixed. Yes.
I think, Dom, this is something we can sort out once
Offline,
generated a pull request. Yeah, because I think it's like yeah, a little abstract. The other question, Jay, I have for you is in the issue that you wrote up, you also mentioned that you've done some work on stopping criteria.
Right. Yeah.
How did you implement that, and like, I guess, how would you like to see that implemented within SimPEG?
So like the stopping criteria that I was talking about is just taking like our current model and then the last model, taking the difference and then just like normalizing the last model. So it's kind of like a percentage update of the model. And the way that I did it right now is just I added a new stopping criteria in the optimization class because like I know other better, like I didn't know any other better way. But yeah, that's how I implemented that.
Yeah, that's totally fair. I think, have you seen the way that directives work in SimPEG?
Yeah, more or less.
Yeah, because I think that this could be fitting as a directive, but we do need to think, we'll need to actually think through how we compute stopping criteria and sort of what are like the ands versus ors, I guess. Because when we talk about a joint inversion, another thing that you could think about doing is making sure that you are sufficiently fitting all of your data misfits, in which case, you know, satisfying only a single stopping criteria for a single term like gravity, we shouldn't actually stop the inversion. We should wait until all of the stopping criteria are satisfied. Whereas you might also want to have a stopping criteria where it's like, okay, fit the data misfits, or as Jay is doing, if there is like minimal decrease in the model changes, then you could also stop there. So we'll just need to have some of that logic, I believe, is in SimPEG, but it's not necessarily completely transparent at this point.
Do you think we could, like, let's say we start reworking optimization, that we should actually always have a base directive, let's say a phi d star or something, but it'd be great if we could add append like a list of criteria or take some out, you know, without having to go deep inside the class, the optimization class. You know what I mean?
Yeah, yeah.
Because right now we hardwired like 3 or 4 of them, but it's either not enough or it's too much. But it's hard to play around with.
Yeah, I completely agree. It would be nice to be able to have
a list, right?
A list or some sort of logic statement where you could end up saying, like the example that I just mentioned for a joint inversion is like satisfy both of these data misfits, or like stop changing things, and on either of those cases I will stop. So yeah, I don't necessarily know how we store the ands versus ors yet. do you know what I'm saying? Mm-hmm. But with that, yeah, I agree that it would be nice to have a list where we basically say, like, if any of these things are satisfied, then you can stop the inversion.
So, could we just have like a stopping criterion in class that defines how to, like, the custom operators, like the ors, ands, and then just create them literally using ands and ors in Python, then pass that all at once?
Oh, that's cool. Yeah, I think that would be really cool, Joe.
I feel like that'd be a logical way to do it. We'd have to look at it a little bit more, kind of the same way that the combo objective function works, just a combo stopping criterion.
Yeah, yeah.
And then it would be a bunch of function handles type of thing that takes a model and then does something, yes or no. Is that what you have in mind, Joe?
Yeah, essentially.
I don't know if it would be a function handle, but the idea being that it would be like a list of directives, or like, sorry, not a list, a set of directives. So let's say I have directive 1, which is like target misfit on phi-d1. I have directive 2, which is target misfit on phi-d2. I want an and on those two, brackets, or like there's minimal change in the model updates. And so actually to be able to just write that out in code and say like phi-d1 star and phi-d2 star, brackets, or this guy, and have just like that logic written as you would write a statement in code.
Yeah, and then hit it at the end of each iteration. Yeah, like a directive. That makes total sense. I like it.
Jay, does that make sense? What we're
it does. Yeah.
Okay, cool. Very cool. Are there other questions or things like that that came up as you were getting up and running? Things that you think that like are clunky or that we need to rethink? I don't know if you followed if you had a chance to see the blog about some of the stuff we are trying to update within the simulation, like the way that the problem and survey are kind of structured. Yeah, but if there's any like thoughts that you have, especially with respect to joint inversion, that you think we should be thinking through, that'd be great to hear.
No, nothing special.
Okay.
Yeah, I've actually been able to run a few joint inversions just using what I've done so far.
Excellent. So I think with respect to your issue that you've opened up here, and for working to start getting some of these things in SimPEG, I'm wondering if starting with the regularization and getting the cross gradient is like a good first pull request, because I think it's reasonably well scoped. And both Dom and I can jump in and help out there. So what we could do is, I think actually, see what you think about this. Totally open to suggestions. But I could start a branch where we basically break the regularization into folders. So instead of just like a giant, regularization file, we actually break it up into folders. And then you could go in and add, we can have one that's basically specific to joint, and you could go in and add the cross gradient term there. Would that make sense?
I think that makes sense.
Okay. I think the way we'll do that, if this is okay with you, is actually off of the simulation branch. So it's like one level beyond where SimPEG currently is. Or is that, do you want to be able to work with the current version of SimPEG with your combo, or sorry, with the cross gradient term?
Yeah, well, I'm not familiar with the simulation. Is that like up there, or?
So what we're talking about doing, and this shouldn't change too much from the outside, like from the user perspective, not too much should change. But what we're trying to do is, you know how when you set up the forward simulation, you had to do problem.pair survey? We're basically trying to get rid of that. So to have the survey be much more lightweight and really only store sources and receivers, and then have the simulation class do all of the heavy lifting. So the simulation knows how to compute the fields. It also knows how to compute dpred, the predicted data. And the survey no longer deals with any of that. So it's sort of a major structural change within SimPEG. So that will be the next major iteration of SimPEG. And so I was sort of thinking we could just jump on to those developments. But in the same breath, I'm wondering if if we just branch off of master, because then all of your current codes will still work. And that might be a bit easier rather than sort of, changing multiple things at once. If we go right off of master, the examples that you're using would still all work, and the changes would be focused very much to just the way that you're calling the cross gradient regularization.
Okay. Well, like the coupling, like the cross gradient that I defined doesn't like depend on the forward problem.
Right. Yeah, so let's do it off of master, and then we can just incorporate these changes upstream later on, and that'll be totally fine.
Okay.
I haven't checked, Lindsay, but you didn't do anything to regularization other than lowercasing the r, did you? On
No, there shouldn't be anything else that changed there, so it shouldn't matter. Yeah, where we make this change. Yeah. Yeah. Okay. Cool. Well, we can give that a go. So we'll get that. We can get that started. Yeah, this week.
Okay.
Cool. And I'll add you to the SimPEG organization so that you can just like push directly there, because that's a bit easier than working off of a fork, especially if we want to collaborate. Do other folks have questions for Jay? I've been talking lots.
So one thing that I think I overlooked is like all the work that I've done is just using tensor meshes. So I don't know like how the cross gradient would behave using other different types of meshes.
It should. I mean, we can take a look. It should abstract quite easily, and that's something we can test out because all the names of the operators and things like that are the same. So when you start a pull request, we can just generate an example that tries it on the octree mesh and see what happens.
Okay, great.
Yeah, I'm sure we'll have more conversations once we see the class that you created, and then you can go from there.
Okay.
Perfect. And then, are you on Slack?
Yeah, I think I think I got the link when you were in Houston.
Okay. If not, feel free to ping and I can send it again. But that's a good place to connect and like ping if you have sort of specific questions as you're developing stuff. We're all on there.
Okay.
Excellent. Well, I don't have anything much else for today. Does anybody else have things you'd like to bring up or thoughts for next week?
I'll do my best to have the PF done by next week, and then we can talk about it.
That'd be awesome. Cool. Okay. Well, with that, thanks everyone. And thanks very much, Jay, for joining us today and sharing all the work that you've been doing. This is really exciting to see you pushing on joint inversions in SimPEG. You know, we've like tried to think through so many of the pieces to try and make this happen, but there's not too many examples of it yet. So you're really one of the first people to be pushing hard on extending the joint inversion capabilities. So it's super awesome.
Thanks.
Cool. All right. Thanks, everyone. I'll see you next week.
Thanks, Lindsay.
Bye.
Bye.